Okay, here we are doing some calculations of empirical formulae, and we'll try 3 calculations, and I will also leave you with 2 calculations to do yourself, and I'll give you the answers so you can actually see if you're doing them right. In general, empirical formula calculations are quite straightforward, and we'll have a look at 3 examples to see, and there is a general method to use as well. So in this little video we're going to be doing learning about the definition and then trying some calculations, and there will be one calculation where we have to work out the molecular formula as well. Okay, so let's start off then with our first well, before we do that, some general rules. Well, before we go to the general rules, definition. You need to know the definition for empirical formula, and you can find that in the glossary of your textbook. But basically it's the simplest whole number ratio of atoms of an element in a compound. Okay, so you need to learn the definition. Okay, let's have a look at the general rules. Okay, general method. Whenever you're given the information in a question, for example, here's one question, look, you write down the first thing is the elements. In this case, calcium nitride contains this much percentage by mass of the metal. So calcium nitride, so there's 2 elements involved here, calcium and nitrogen. So you'd write down here calcium and nitrogen. Then you write down the percentage or the mass. In this case they give you percentage, so you write down the percentage underneath each one. Then you divide by the atomic mass, so you can use your periodic table to find the atomic masses. So divide the percentage by the atomic mass, get a value, and get a value here as well. And then you divide by the smallest of the 2 numbers you just found, and you'll get your ratio. Okay, right, let's try this example then, calcium nitride. So let's try it here. Right, write down calcium. Oops, calcium and nitrogen. You may get 3 elements. Okay, calcium and nitrogen. Percentage 81.1, and notice they don't give you the percentage of nitrogen, so because it's percentage you just need to subtract 81.1 from 100 and you will get 18.9%. There we are. And then you divide by the atomic mass. So atomic mass of calcium 40. Be careful you don't divide by the atomic number. And 14 for nitrogen, and that should give us let's see now, that should give us 2 and 1.35. Okay, so far so good. And now you come to the last part, which is divide by the smallest of the 2 values. Smallest of the 2 values is 1.35, so 2 divided by 1.35, 1.35 divided by 1.35, that is obviously 1, and that divided by 1.35 is 1.48. Now this is approximately 1.5. When you get 0.5, 1.5, 2.5, 3.5, etc., or even 0.5, then you can't round up and you can't round down. You have to now double everything. Okay, so what we do is times everything by 2, and we get the ratio 3 there and 2 here. So the answer is calcium 3 and nitrogen 2. Okay, there we go. So remember, a special case, when it's 0.5, you can't round up, can't round down, you double everything. Okay, let's try another question. This one here, get that one. Indium forms a compound X with hydrogen and oxygen. Compound X contains this much percentage indium, 1.8% hydrogen by mass. Okay, and it's also got oxygen in it. So this time you've got 3 elements across the way. You've got indium, you've got hydrogen, and you've got oxygen. So use the same rules as before. Remember what they were? You've written down the elements, write down the percentage. In this case it is percentages. Right, so write down the percentages underneath each element, divide by the atomic mass from your periodic table, and then you divide by the smallest value, and then if it's close to 1.5 or 2.5 or 3.5, you must multiply by 2. If not, you round up to the nearest whole number. Okay, right, I'm going to leave you to do in this question. Alright, leave you to do that yourself, and I'll tell you what the answer is. It is INH3O3. Right, let's see if you can have a go and get this answer. Alright. Right, in the meantime, let's go to question 3. That one there. Got the right one? Yep. Oxide of nitrogen. Let's do this one together. Okay, oxide of nitrogen contains this much nitrogen, so determine the empirical formula. So we've got the elements, nitrogen and oxygen only, 25.9%, and therefore oxygen will be 74.1. Subtract that from 100. Now you divide by the atomic mass, so divide by 14 there, and divide by 16 there, and we get 1.85 and 4.63. Now divide by the smallest, which is that. So 1.85 divided by 1.85 is 1, and 4.63 divided by 1.85 is 2.5. Okay, notice you got 0.5, so you're going to double everything, and you get 2 and 5. So our answer is N2O5. Great. Let's go to the next one. All right, and the next one is that one there. Right, this one here, magnesium, nitrogen and oxygen. Okay, this one again I'm going to ask you to do yourselves. All right, you've got magnesium, you've got nitrogen and oxygen. So nitrogen and oxygen, and I'll tell you the answer for this. Empirical formula is MgN2O6. So have a go, and that's the answer. Okay, right, I'll do one more question. We'll do that together. Right, and this one here. So you notice this one, it asks us for the molecular formula too. So let's do this one together. Right, we've got a compound X contains carbon, hydrogen and oxygen. There's the percentages, and it doesn't give us the hydrogen, does it? Yes it does, but it doesn't give us the oxygen. Right, let's work it all out then. So carbon, write the elements first. Carbon, hydrogen and oxygen. Carbon, and has only 38.7% carbon, 38.7% carbon, and 9.68 hydrogen. 9.68% hydrogen. Oxygen we have to work out, and that comes to 51.62. 51.62. All these three add up to 100. Okay. Next thing, we divide by the atomic mass. That's 12. You can use your periodic table. That's 16, and we get a value of 3.23 there. Be careful not to round down too quickly. So 3.23 fine. 3.2 not yet. Don't round down too quick. 9.68. 3.23. Okay, right, now divide by the smallest, which is 3.23. So 3.23 divided by 3.23 is 1. That divided by 3.23, if you do that on a calculator, you will get 2.997, which is 3. And that divided by 3.23 is 1. And so there you are, you've got CH3O. That's your empirical formula. Okay. Now, calculate the empirical formula, done, and deduce the molecular formula of X given the molecular mass is 62. Now, in order to work out the molecular formula, we need to know the empirical formula mass. So if you add up these values, 1 carbon, 3 hydrogens and 1 oxygen, you will get 12 plus 3 plus 16, 15. That comes to 31. 31, right? 31 mass. And they're telling us that the molecular mass is 62. So molecular mass divided by the empirical mass equals 62 divided by 31 equals 2. So all you do now is you multiply your empirical formula by 2. Right, let's do that. So 2 times CH3O equals C2, every element is multiplied, H6 and O2. And there is your molecular formula. Okay, and that was empirical formula calculations.